Okay, this is a very difficult concept, so I'm going to go through the 3 problems from your homework. Sorry, third period, I didn't think to tell you specifically what 3 to do, so these are the ones I told the other classes to do. Remember, the first step is to solve either equation for one of its variables. That means we're going to rearrange either equation, whichever one is easier, so that it says either x equals something or y equals something. Looking at these, this is the easier equation to rearrange. So I'm going to copy it down in a clean spot that I can work with it. And it doesn't matter whether I solve for x or y. In this case, I chose to solve for y. So I subtract x from both sides. On the left side, x minus x is 0, so that leaves me with y equals, on the right side, 6 minus x. So now I know what y equals. Even though it's not a number, I know that it has to equal 6 minus x. Because this right here is the same thing as this, it's just rearranged. In any case, now I have something for y that I can replace y with. And why do I want to do that? Well, once I rewrite it, you'll see why. So let me clear off a piece of space here, and let me write my equation. Negative x plus y equals negative 2. I haven't changed it. It looks exactly like it is here. But now if I plug in this snippet from the other equation, and I plug that in for y, look what happens. Negative x plus, well, instead of y, I'm going to write 6 minus x, right? 6 minus x in parentheses equals negative 2. Look, I only have one variable now. I can solve this. If I were to try to solve this with 2 variables, I end up with a line. If I can solve this with one number, I end up with a single value, a single number. So now let's go ahead and solve. Remember, I need to distribute into those parentheses. So I'll rewrite it with that distribution. Negative x plus 6 minus x equals negative 2. Combine my like terms. Negative 2x plus 6 equals negative 2. I need to isolate my x. So I'm going to get rid of this. I'm going to add or subtract first, and then I can deal with my division. It's just easier. You can do it the other way and get the right answer. This is easier, though. So I'm going to subtract 6 from both sides. I'll end up with negative 2x equals negative 8. Still need to isolate x, divide both sides by negative 2. I end up with x equals positive 4. Okay, I now have a value for x. So now I can take this and I can plug it in or substitute it in to either of my original equations. I'll pick the easier one. X plus y equals 6. Instead of x, though, now I can say 4. 4 plus y equals 6. Subtract 4 from both sides. And I learned that y equals 2. Okay, I have a value for x. I have a value for y. I have a point. My x, comma y. How do I know whether or not this is my true point? I'm going to have to check my solutions, and by now you know how to do that. Let's do the middle one. I picked the first equation because it looks a heck of a lot easier to solve for a variable. I think I'm going to solve it for x because all I have to do is get rid of that negative 2y. Add negative 2y to both sides, and I have x equals 9 plus 2y. This equation now has been solved for x because I have x all alone on one side. Everything else is on the other side. That's as far as I can go if all I had was this equation. Okay, but now I have this blob of stuff that I can pop in for x. So let's do that. I'll copy the original equation, 3x plus 2y equals negative 13. Rewrite it again, but instead of x, I'm going to write 9 plus 2y. All I did was plug that in instead of x. Okay. Copy down the rest of my equation. Plus 2y equals negative 13. Multiply, or be sure to distribute. 3 times 9 is 27. 3 times 2y is 6y. Plus 2y equals negative 13. So I got the rest of my equation there. Combine my like terms. I get 27 plus 8y equals negative 13. Subtract 27 from both sides. I'll end up with 8y equals negative 40. Divide both sides by 8. I have y equals negative 5. Now I have a value for y. I know what y has to be for both of these equations to be true at the same time. Okay, so now I can take that y and I can replace that in. I can substitute that for y in either equation. Again, I'm going to take the equation that I think is easiest, x minus 2y equals 9, rewrite it, but instead of y, I'm going to substitute in negative 5. So x minus 2 times negative 5 equals 9. Do you see how important it is to write those parentheses? Because otherwise I might think that I was subtracting 5. But no, I'm multiplying these, right? So let's distribute. So I get x plus 10. Negative 2 times negative 5 is positive 10. Equals 9. Isolate x. So I've got to subtract 10 from both sides. I end up with x equals negative 1. I now have an x. I now have a y. I can write that as an ordered pair. Negative 1 comma negative 5. How do I know whether or not this really is my solution? That's right. I'm going to check it. And how do I check it? I check it by plugging it in to both equations. Okay. I'm going to skip this one for now. I'll move on to today's warm-up. If you were absent and you didn't do this warm-up, I suggest that you pause and do it on your own, please. All right. So I'm going to assume that you paused it and noticed something a little odd. So let's go ahead and solve it. Let's see if we can do it a little bit more quickly than we have before. So I picked this equation to solve for. Or rather, to solve for one of my variables. I'm going to go ahead and solve it for y. So copy it down. Negative x plus y equals 3. To solve for y, that means I need to move everything else to the other side. So how am I going to get rid of a negative x? That's right, I'm going to add x to both sides. Those cancel. I end up with y equals 3 plus x. I now have an expression that I can substitute in for y in my other equation. Use some space over here. Rewrite my original equation. Negative 3x plus 3y equals 4. Substitute this in for y. So negative 3x plus 3 times, instead of y, I'm going to write 3 plus x in parentheses. Copy down the rest of my equation, equals 4. I've got to distribute before I can solve, or that's my first step in solving. So I'll rewrite it again. Negative 3x plus 3 times 3 is 9, plus 3 times x gives me 3x. Copy down the rest of my equation, equals 4. Combine my like terms. I end up with 9 equals 4. Well, that's weird. That's, of course, not true. Well, what have we always known is the solution when we end up with something like this for a multi-step equation? That's right, we are told there are no solutions. So there is no point where both of these lines connect. There's no set of numbers that are true for both of these equations. There is no solution. If at any point you end up with an untrue math statement like this after you got rid of all your variables, it is no solution. Okay. Let's look at the next problem on our warm-up. So go ahead and try this on your own. Pause if you haven't already. All right, so those of you, once you've tried it on your own, or those of you in class, please don't write anything down yet, because I'm going to lead you down a couple of wrong paths for a reason. You'll see why. So if I look at these equations, it looks to me like this one is easier to solve because I already have y on one side. I just need to divide each term by 24. But if I do that, what do I look at? Well, if I divide each term by 24, well, now I'm going to have really weird fractions here. And I don't know about you, but I don't like to work with fractions. So forget that one. So I'm going to solve the top one. So if I copy that one down, still don't write anything down. So I have negative 2x plus 6y equals 4. So it looks to me, like I said before, I want to deal with positive numbers, so I'm going to go ahead and solve for y. So I'll add 2x to both sides. I'll end up with 6y equals 4 plus 2x. I'll divide each term by 6, and oh, I get those icky fractions again. So no. Sometimes you've got to look at it, think it through a little bit before you decide what variable you're going to solve for. So I'm actually going to solve, now you can start writing this down. I'm actually going to solve for x. So I've got negative 2x plus 6y equals 4. I need to get x by itself. So first I'm going to add and subtract to get the stuff rounded away. So this 6y is in my way. Subtract 6y from both sides. I end up with a negative 2x equals 4 minus 6y. Now I need to isolate my x still. It's being multiplied by negative 2, so I'm going to divide each term by negative 2. And I will end up with x equals 4 divided by negative 2 is negative 2. Negative 6y divided by negative 2 is a positive 3y. Okay, I now have a blob of stuff. I have an expression that I can substitute into my other equation. I can substitute that in for x. So I'll make some space, copy down my original equation. 24y equals 16 plus 8x. And I know you think I'm wasting time by copying it down, but trust me, it leads to fewer mistakes. And right beneath it, I can copy it down, substituting this in for x, because this is what x equals. So this is what I can plug in for x. All right, so 24y equals 16 plus 8 times negative 2 plus 3y. That's right. Well, first thing I need to do is distribute. So I'll copy down the first part of my equation, 24y equals 16. Now, positive 8 times negative 2 is going to give me negative 16. And 8 times 3y is going to give me positive 24y. Combine my like terms, 16 and negative 16 equals 0, so I'll have 24y equals 24y. Hey, no kidding. I'll even take it a step further. Divide both sides by 24, and I have y equals y. It's a true math statement. I still have variables, but this is the identity solution. So this means I have an infinite number of solutions. So I have infinite solutions. If I end up, when I'm solving this kind of system, with y equals y, or if I end up with a number equals the same number, a true math statement, then that is infinite solutions. Again, though, if you're ending up with numbers, that means that you have gotten rid of all your variables and you have a true statement. Because if you still have variables, unless it looks exactly like this, if you still have variables, you're not at a solution yet. Or you don't know whether or not you have a solution. All right, so there were a few problems from the homework and our warm-up problems. See you in class.